Hey guys, Merry Christmas. Let's take a look at number 58, length of the last word. We're given a string S consists of upper lowercase alphabets and empty space characters. Return the length of the last word in the string. If the last word does not exist, return 0. A word is defined as a character sequence of consists of non-space characters only. So this is the word. The last word is world, so the length should be 5. Well, this one is pretty straightforward. We just loop through all the characters and check if it is a word or empty space. If we met empty space and previous one is not empty space, then this is the end of the word, right? If previous is empty, but this one is the word, the alphabet, then it's the start of the word. Which means for each character there's a state of what it should be. So we could just keep it a state machine. Let's say state is state. There were how many states? There is one start of the word, and then in the middle of the word, and then end of the word, right? Yeah, we can just track the start and the end, so we can just keep 2 states. No, 3 states. Word start, in the middle, and the end is in the word. Or just 2 states, which one is we start a word and then we should end a word. Yeah, and the other state is in a white space. Yeah, okay. So the state, let's say we use string to describe the state. One is a white space, and then in the word, right? Word. Okay, so the first we should the start we should make it the white space, right? Because for the first character it must be, if it is white space, it is white space. If it is not white space, then it should be start of the word, right? So let state equals white space. Okay, for let I, we travel through the string. Okay, if S if it is empty space, if it is empty space and the state is not white space, then this is end of word. If Si is not an empty space and the state is not word, oh god, then this is start of word. Yeah, so actually we can just memorize the index of the start and the end, right? If we met the end, then the previous one must be the start. Okay, so let's start Okay, start index of word equals undefined. Okay. If it is the end of word, then we say if there is start of word, okay, we just use -1. If it is bigger than -1, then we return I minus start index of word. And actually +1. This is an n. Yeah. And if it is empty, if it is not, then it should be 0. The last index does not exist. But the previous state is not white space. There must be words. So this cannot. Should be no such case. Okay. Oh no. We should not return. We just should update it. Okay. The end of word should be this is empty, or I equals s dot length -1. This must be the end. Okay. No. We should move it to the next one. Yeah. With this is the end. So there is a case that there is no last word. If there is last index, we return this. If there's no index, we return 0. Oh no. No. We should not wait. We should not return right. We made some empty space. We should just update the index. Okay. Last index. And that there should be last length equals 0. Yeah, when we met this, we should just update the index. So the index should be I, right? And if there existed previous index, because previous is not white space, it must be a word. So last length must be I minus starting index of a word. Yeah, and if it start a word, then we update the index I. When everything is traversed, we return last length. This is a kind of straightforward, right? So we're just memorizing the index of start and end. We were making the end of a word like the making an empty space, white space, or the end of the string. We update to the last length, right? If we go to this space, we update the length to I minus this index would be 1, 2, 3, 4, 5. And then when we made something is not in a white space, and the previous one is not, and it is not in the word, then it should be update the start of index, right? This is the new start, and we should update the state. When we something, this is not white space, we update it, and the state should be now white space. And now we got a word, so state should be word. Okay, let's try this for once. Let's say the time. Everything is traversed once, so on. This is obviously on. Space. We use 3 extra variables to keep track of the result, so it's constant. Okay, let's submit. Cool, we accepted. And yeah, there's nothing I think fancy about this problem. We just listen, just understand the problem, understand it thoroughly, and just traverse through the string and keep track of the data by a state machine. This is kind of helping, right? Yeah, we're checking each character and checking against the state of current character or previous character. Yeah, current, what is going on, and decide what we should do next. So state machine, yeah, it's very cool. It's really in my front-end developing experience, it's very helping for some cases, like when we're doing some async method, like doing some API request. So before the request, during appending, waiting for the response, and after response or error. So it's just like a state machine. We just jump through one state to the next one state. Yeah, so that's all for this problem. Hope it helps. See you next time. Bye bye.